please open up your Chapter 9 note packets to Section 9.4b. In this lesson, the objective is to apply the zero product property. Before we apply it, we have to know what it is. And the zero product property says if two numbers, x and y, multiply to equal 0, then x equals 0, y equals 0, or both x and y equals 0. Once again, the zero product property. If two numbers, x and y, multiply to equal 0, then x equals 0, y equals 0, or both x and y equals 0. So what this property is saying, basically, is that we have two numbers. We have no idea what they are, so when we don't know what a number is, we use variables to represent it. So we're going to have x and y. And what this property is saying is you take two numbers, x and y, but we know they multiply to equal 0. So therefore, I take x times y, and it equals 0. So what this is saying is x could be any number. Remember, we chose two numbers. X could be any number. And when we multiply it by y, we're getting 0. So x is any number, 1 to a million. It doesn't matter what number it is. But when we multiply it by y, we're getting 0. So any number times what is 0. That means y has to be 0. Because if x is any number, and we multiply it by y to get 0, we're multiplying it by this y to get 0, that means y has to be 0. So in this scenario, y is 0. Now we could do x times y again, multiply to get 0, but this time we can have y be any number. So y could be any number, 1 to a million, it doesn't matter once again. But when we multiply it by x, we get 0 again. So that means, once again, y is any number, so that means x has to be 0. So in this scenario, x is 0. So we've done x equals 0 and y equals 0. But there's a third option. Both x and y could equal 0. So once again, we have x times y equals 0. And in this last one, we take 0 times 0, and that's 0. So here, both x and y are 0. So in the first example, right here, we did y equals 0. Then over here, we did x is 0. And then finally, right here, we did both x and y are 0. So now let's take a look at applying this zero product property to some algebra. So here we have the quantity x minus 4 times x plus 2. Now back here in the zero product property, they used x and y. Keep in mind, though, x and y just represent any number, or it could also be any expression. So right here, this x minus 4, I'm going to highlight that in blue. And then the x plus 2, I'm going to highlight that in purple. So instead of doing x times y equals 0 like we did right here and right here, instead in this example, since x is already in there, I don't want to confuse you with this, we're going to do blue times purple equals 0. So that means this whole blob here could be 0, or this whole purple blob could be 0. Because when we multiply them, when we multiply the blue times the purple, we get 0. So we don't know. It could be, the blue could equal 0. The purple could equal 0, or both could equal 0. Since we don't know which one could equal 0, we're going to set them both equal to 0 and solve for x. So we're going to set this x minus 4 equal to 0. And then we're going to set x plus 2 equal to 0. So we add 4 to both sides, and we get x equals 4. We subtract 2 from both sides, and we get x equals negative 2. So here, we get two answers for x. We get x equals 4 if blue is 0, and x equals negative 2 if purple is 0. Both answers are correct, and both answers are what you need. So the correct answer here is x equals 4 and x equals negative 2. That would be the correct answer. X equals 4 and x equals negative 2. Okay, let's take a look at the next example. We have x minus 5 times x minus 1 equals 0. Once again, I'm going to make this blue, make the second one purple. So we have blue times purple equals 0. So once again, the blue could equal 0. The purple could equal 0, or both equal 0. We don't know which one could be 0, so we set them both equal to 0. We're going to set x minus 5 equal to 0 and x minus 1 equal to 0. So x minus 5 equals 0, x minus 1 equals 0. Add 5 to both sides over on the left, and we get x equals 5. Add 1 to both sides, and we get x equals 1. So your answer here is x equals 5 and x equals 1. All right, let's look at some examples now where we apply this to factoring. Now remember, when we factor, we're solving for the x-intercepts of a quadratic function. So this equation here, C, this would typically be y equals x squared minus 3x. Now, since we're solving for the x-intercepts, we place 0 in for y. Solving for x, substitute 0 for y. So we have 0 equals x squared minus 3x. Now from here, we look for our greatest common factor, that being x, and we're going to factor that out, x. And then what's left inside the parentheses is x minus 3. And now once again, we have this blue and this reddish color. So we have, this could be 0. The green times red now. So green could be 0 or red could be 0. Since we don't know which one is 0, we're going to set them both equal to 0. So we're going to set x equal to 0 and x minus 3 equal to 0. We add 3 to both sides. So x equals 3, and this one over here is pretty simple. There's nothing to do. So we just have x equals 0. So x equals 0 and x equals 3. Now, since we're solving for x-intercepts, we want to write our answer as an ordered pair. Remember, ordered pair is x comma y. So ordered pairs is x comma y. This is how your answer should look. So the x-intercepts, we have a 0 for the x, Now, what did we substitute in for y? We substituted 0 in for y. So we have 0, 0, and then we have 3, 0. Looking at letter D. Once again, we have y equals 6x minus x squared. We substitute 0 in for y. So we have 0 equals 6 minus x squared. First thing we want to do is write this in standard form. So it's going to be 0 equals negative x squared plus 6x. From here, we factor. Look for the GCF. Remember, this front value is a negative 1. Anytime you have a negative in your a value, you have to factor out a negative value. So 0 equals, factoring out a negative, we take out a negative x, and we're left with x minus 6 inside the parentheses. From here, I'm going to shade again. We have this greenish color, and then we have the red here. So once again, we have green times red. So green could be 0. Green could equal 0, or red could equal 0. We don't know which one, so we're going to set both colors equal to 0. So we have negative x equals 0, and x minus 6 equals 0. So on the left, we have negative 1x equals 0. To get rid of that negative 1, we divide by negative 1 on each side. 0 divided by negative 1, x equals 0. On the right-hand side, we add 6 to each side, and we get x to equal 6. Once again, we write our answers as an ordered pair for the x-intercepts, and we get 0, 0. Remember, we did this. We're writing a 0 here because we substituted 0 in for y, and then 6, 0. All right, looking at letter E. We have y equals 3x squared plus 9x. Factoring out the GCF here, when we substitute 0 in for y, we have 0 equals 3x squared plus 9x. Factoring out the GCF, we have 3x. And then in parentheses, we have x plus 3 left. From here, we have this 3x times x plus 3. So we have green times red. So green could equal 0, and red could equal 0. Since we don't know which one, we're going to set them both equal to 0. So 3x equals 0, and x plus 3 equals 0. On the left-hand side, divide by 3, and we get x to equal 0. Subtract 3, and we get x to equal negative 3. Writing your answer as an x-intercept, we have 0, 0, and negative 3, 0. And remember, we write these zeros for y because we substituted 0 in for y. Right here, we put 0 in for y at the beginning of the problem. Okay, looking at letter F. For this one, we don't have y equals. We have 4x squared equals 2x. We need to get one of those two sides to equal 0. So we have 4x squared equals 2x. So I need one of these two sides to equal 0. Well, if I have 2x over here on the right-hand side, to get that to go to 0, I just subtract 2x. Because 2x minus 2x cancel, and I'm left with 0. So we have 4x squared minus 2x on the left-hand side. Keep in mind, you cannot combine these. Those are not like terms. That 4x squared is a double-headed cow. That 2x is a single-headed cow. They cannot be combined. So we have 4x squared minus 2x equals 0. Now we go through the same process. What can we take out of 4x squared minus 2x? What is the greatest common factor? Well, that would be 2x. And then left in the parentheses would be x minus 2 equals 0. From here, we have this 2x, and we have the x minus 2. So once again, green could equal 0, or red could equal 0, or both. I'm repeating this over and over to get this into your minds. So we're going to set them both equal to 0. 2x equals 0, and x minus 2 equals 0. Divide by 2 on the left, so x equals 0. Add 2, so x equals 2. And now the x-intercepts, writing it as an ordered pair, we get 0, 0, and 2, 0. Okay, looking at the next example, letter G. We have negative 2x squared minus 8x equals 0. So this is the same as saying negative 2x squared minus 8x equals y. Same thing. So negative 2x squared minus 8x. We substitute that 0 in for y, so it's equal to 0. Once again, we're looking for that GCF. Remember, this is your a value, this is your b value, and whenever your a value is negative, we have to factor out a negative. So looking for the GCF here, that's going to be a negative 2x, and then in parentheses, we're left with x plus 4 equals 0. Now, once again, we have this negative 2x, we have this x plus 4. Either the green or the red could equal 0, so I'm going to set them both equal to 0. Divide by negative 2 on the left-hand side, and we get x equals 0. Subtract 4 on each side, x equals negative 4. So once again, we have two answers for x like we've had this whole time, and the x-intercepts are 0, 0, and negative 4, 0. Okay, looking at letter H, I want everyone to just throw an x on the end of that negative 32. There should be a negative 32x there. So this problem is just like letter F that we did a couple minutes ago. So here we need one side to equal 0, and I'm going to set this right-hand side to 0. So to do that, I have a negative 32x on the right-hand side of this equation, and I'm going to add 32x to both sides. Negative 32x plus 32x cancels, leaving me with 0. And now, once again, this is 16x squared and 32x. We cannot combine. So we're just left with 16x squared plus 32x. Now, once again, we look for that greatest common factor. The greatest common factor of 16x squared and 32x is 16x. And now we have left inside the parentheses x plus 2 equals 0. Now from here, once again, we could have this 16x be 0, or x plus 2 could be 0. So since we don't know which one, we're going to set them both equal to 0. So we have 16x equals 0, x plus 2 equals 0. Divide by 16, so x equals 0. Subtract 2, so x equals negative 2. And now we write it as an x-intercept, 0, 0, and negative 2, 0. Okay, that concludes this video lesson. If you have any questions, please make sure you ask one of your math teachers.